Hi there, and welcome to our lecture on elements and also the periodic table. This will be Atoms 3 of Unit 3. Our key ideas: how are elements arranged on the modern periodic table, and what does each element family have in common? So looking at the arrangement, the modern periodic table organizes elements by atomic number. When the elements are arranged in this way, elements that have similar properties appear at regular intervals. So every once in a while, or every so often, the properties that fall within a particular group or region tend to be similar. So as scientists learn more about the structure of the atom, they improve the arrangement of the periodic table by arranging by atomic number, which is also the number of protons. So periodic law is defined as the law that states that the repeating chemical and physical properties of elements change periodically with the atomic numbers of the elements. So looking at our periodic table here, the atomic number is shown above the element symbol, and as we were to read it as if it were a book, start at the top left and we go left to right, so you can see that hydrogen has a 1 going across, helium's 2, and then lithium 3, beryllium 4, and then so on, 5, 6, 7, 8, 9, 10, and it continues on like that. The reason there's a large gap in here is hydrogen has more similar properties to this first group of elements. Helium has similar properties to this last group of elements. Helium's kind of unique. It could fall here next to hydrogen as well, but it tends to have properties more like these last elements. So here's the way that our current periodic table is laid out and arranged. We'll be using this more as we move on through the semester. As we move across the periodic table from left to right, the elements become less metallic, so they become less metal-like. And as we move across the periodic table from left to right, we refer to this as a period. So this is the horizontal row of elements in the periodic table. And then elements in a group have similar properties, and a group is typically a vertical column, so an up and down column of elements in the periodic table, and they share similar properties as well as the same number of valence electrons, and we'll get to the valence electrons shortly. So just kind of get a visual here. A period goes from left to right, and a group goes up and down. So let me show that on here. So a period goes across. It could be up here too. These are periods. And then groups go up and down. Alright, so what does each element in the family have in common? In general, the elements in a family have the same number of valence electrons, and the valence electron is the outermost electrons. So looking at our periodic table here, our small periodic table, this is referred to as group 1 here, the one that starts with hydrogen. These guys all have 1 valence electron, or 1 electron in their outer shell. Group 2 is the one that starts with beryllium here. These ones have 2. Group 3 through 12, this red section in the middle, it varies. It can be anywhere, well, let me just scribble that out. It can be anywhere from +3, we can have +1, we can have a different number of valence electrons in this section. So we're saying that they vary. Group 17 this last one, or second to last one, has 7. And with the exception of helium, just draw a little box around there. Oops. Starting with neon, we've got 8. And hydrogen only has 2. So we're going to look at these families a little bit more. So metals are soft and shiny. They have many similar melting points, boiling points, and densities. They can be reactive to form positive ions. And transition metals are in the middle of the periodic table. So these red guys in the middle here I refer to as transition metals. Or if we just take it out of the periodic table form, so you can just see those transition metals. Non-metals, we've got a couple different groups we're going to look at. Noble gases are the very last group, very last column, referred to as noble gases because they're relatively what we call inert. And I'm just going to kind of make a side note. Inert means not reactive. And instead of existing as molecules like the rest of the nonmetals do, they exist as single atoms. So you'll find them by themselves typically. Then we have halogens. Halogens is the next to last or second to last, or group 17, starting with fluorine. They combine easily with metals to form salts, so we can form different salts with metals. And all we have to do is add a single electron to make these stable. So they're missing just one electron in their outer shell to become stable. We'll talk more about becoming stable in the next lecture. And then finally, carbon can form many compounds. And there's millions of carbon-containing compounds. There's a whole branch of chemistry that's just devoted to carbon-containing compounds. It's referred to as organic chemistry. It gets pretty complex, but it's very essential. This is the chemistry of life, is organic chemistry. It's a very important element. And the reason it is so important, it's got 4 valence electrons, and it wants to have 8. So it has kind of that in-between. It can either lose or gain electrons based on whatever it's reacting with. Our last family is semiconductor, also referred to as metalloids. And these semiconductors or metalloids are able to conduct heat and electricity, and it depends on the conditions that they're present in, but they kind of have properties of both metals and nonmetals. So they fall between. We've got a picture here. So they're over on this right side of the periodic table. We've got the nonmetals that are just to the right of those, and then our metals are to the left. So our nonmetals we find here, and then our metals are over here. So, thanks for listening.